let's see. Let's see, have we let people in? I can't tell. The bulk of you, more than half thought it was more than 20%, and 17% of you thought it was 10 to 20, and 11% from 0 to 10. So I guess we're going to find out the actual answers to those questions in a minute. So let me just finally say that if you do have any questions, please put them in the chat and we will take them at the end of the presentation. But please restrict your questions to items related to the research topic, which is climate change and climate agreements. Please no questions about current policy anywhere in the world. So with that, I'm going to stop talking and turn it over to Silvana. Thank you very much for being with us.
Thank you very much, Steve, for the generous introduction. And let me see if I can share. Yep. Can you see the screen? Yeah, very good. Okay, so yes, the talk today will be based on my work with Tiloka de Silva, and it's titled Climate Change Pledges, Actions and Outcomes. And as usual, the disclaimer is that these are my views and Tiloka's and will not represent the bank or the MPC. So as you all know, greenhouse gas emissions are a big threat to livelihoods and lives. If I manage to move this, okay, there we are. So and for many decades now, countries have been debating how to reduce emissions and mitigate the impact on the environment. And those debates and negotiations have led to three main international treaties: the Kyoto Protocol, the Copenhagen Accord, and the Paris Agreement. And these pledges made by different countries in the context of the three agreements are hugely different in terms of coverage, timelines, targets, compliance, and measures adopted to implement them. So in my work with Tiloka, we actually studied the three agreements, and concretely we analyzed the pledges made by each of the countries, the actions they took, and the progress made so far. And more specifically, we tried to answer 5 questions. First, what exactly were the targets set in each of the agreements, and did countries achieve them? Second, what was the impact of signing each of the international agreements? Third, did it help to have quantifiable targets? Fourth, of the actions taken so far, which measures were most effective in terms of emission reductions? And last but not least, did the climate measures taken have any indirect impact on GDP growth or inflation? And to set the stage, I will start by showing the trends in total and per capita emissions by region and country. Next, I will show you the results from 3 sets of energy exercises. In the first set of exercises, we compute comparable targets across signatory countries and contrast the pledges that they made with actual reductions in emissions. In the second set of exercises, we study the impact on emissions stemming from signing each of the agreements, from stating quantifiable targets, and from implementing specific measures, in particular national carbon taxes and emission trading schemes. And finally, in the third set of exercises, we study the impact of the climate agreements and actions on GDP growth and inflation, trying to gauge here what the indirect cost of these agreements has been. So let me share a preview of the results. There's huge variation across countries in stated targets and compliance. Countries' compliance with international agreements has been partial at best, with many countries undershooting their targets by big margins. Still, signing a treaty and having quantifiable targets set in the context of the Kyoto Protocol or the Copenhagen Agreement have led to significant reductions in emissions when compared to the counterfactual of countries that did not sign Kyoto or Copenhagen or did not state quantifiable targets. The effects from the Paris Agreement are not yet visible in the data. It might be too early to tell. However, compared to Kyoto or the Copenhagen Accord, the targets in Paris appear much more opaque or less transparent, which might make compliance more difficult to assess and achieve. Let me highlight a couple of other findings. Carbon taxes and the introduction of emission trading schemes both lead to material reduction in emissions, again, when compared to a counterfactual of not having those carbon taxes or trading schemes. Other climate laws or policies do not appear to have individually a significant or quantitatively large impact on emissions. In terms of indirect effects, we find no significant impact of the agreements or measures on either GDP growth or on inflation. So while there might be winners and losers within countries or even across countries, there don't seem to be on net aggregate losses resulting from the measures or the agreements. Now, to answer the questions that we set out, we need to go to the data. And indeed, most of the effort in this paper is in the data. We built a panel database on emissions and activity at the sectoral level for 190 countries from 1971 to 2018. I will not go over the details in this talk, they're all in the paper, but let me just highlight that the most challenging part of the analysis was actually to translate pledges made by individual countries into comparable targets or targeted emission reductions. And that took us a lot of time, given the opacity of some of these targets. Countries sometimes set the targets in terms of sectoral activity, sometimes in terms of aggregate activity. They use different years at baseline, and in some cases use different units of measure. So we needed to unify the data to make them comparable, expressing targets in terms of aggregate emission reductions relative to a common baseline. Also, some targets were stated relative to business as usual scenarios, which sometimes were not available. And we needed to dig deeper in the data to find them. So in some pledges were easy to quantify with the available data, and that was mostly the case with the Kyoto Protocol and the majority of pledges in Copenhagen. But the Paris Agreement has been very challenging, which will haunt us when we try to assess compliance in the future. And there are some examples in this table with different degrees of difficulty or clarity. Again, the general takeaway is that it would be important in the future to have more transparent targets that would make the task of assessing compliance and indeed of complying significantly easier. So let me start with the trends in emissions first. The level of global emissions has more than doubled over the nearly 50 years from 1970 to 2018, which is the sample we have. Global per capita emissions on the right-hand side experienced some declines over the 80s and 90s, but then they were followed by rapid increases from the 2000 onwards. These charts here illustrate the trends at the regional level. The chart on the left shows the levels of fossil CO2 emissions for different regions. The chart on the right shows the level of emissions per capita in the same regions. The biggest growth in total emissions, which you can see on the left, over this period comes from East Asia, depicted in the green dash and dot line here. But in terms of per capita emissions, countries in East Asia are still well below the figures for Europe or North America, as you can see on the right-hand side. Total emissions in Europe and North America seem to have stabilized at a very high level since the 2000s. On a per capita comparison, someone in North America is still contributing much more than double the volume of emissions than someone in East Asia and much more vis-a-vis Latin America, South Asia, or Sub-Saharan Africa. Now, this is important to emphasize because if advanced countries want to lead the way in mitigating climate change, it's important that they start by reducing their own per capita contributions in a more significant way. And this issue becomes even more important if we focus on the stock of gases in the atmosphere rather than the emission flows as in this chart. This map highlights the distribution of emissions around the world in 2018, with the scale going from green to red, where bright red shows the highest level. It is clear that most populous countries, most noticeably China here, records higher levels of emissions. In per capita terms, illustrated in this chart, the top emitters remain rich countries and/or oil producers, including the US, Canada, South Korea, Japan, Germany, and Saudi Arabia. Now, these observations are confirmed by simple regressions. GDP per capita and population have been the key drivers of emissions, as summarized in this table. Roughly a 1 percentage point increase in GDP per capita is associated with a 0.8 percentage point increase in emissions. And population growth moves growth in emissions more than 1-for-1. Oil production also is a big determinant of territorial emissions. So let me now turn to the agreements and targets. This table presents a summary of the 3 international agreements. The Kyoto Protocol was signed by 37 countries, which at the time contributed to about 1/5 of global emissions. The starting year to compute the Kyoto target for us will be 2005. All 37 countries gave numerical reduction targets, but 7 of them did not did not produce information, so we couldn't reconstruct the actual numbers. As I said, different countries use different years to benchmark their reductions. So, for example, some countries would pledge reductions relative to 1990. When we compute the targeted reduction with respect to 2005 for all the countries, it turns out that this group would have seen an increase in emissions or had an allowance for increases in emissions of roughly 7% from 2005 to 2012. The increase is mostly due to the inclusion of Russia here. If we exclude Russia, the joint pledged reduction is in the order of 5% over those 7 years. Copenhagen was a bit more ambitious in its coverage. 100 countries signed it. Of these 100 countries, 59 stated numerical targets, 5 of which we couldn't reconstruct because there was not enough available information. So in all, 54 countries had clear quantifiable targets, amounting to an overall targeted emission reduction of 4% over those 11 years. For countries with non-quantifiable targets, we cannot really compute targets or assess compliance. And finally, turning to Paris in the last column, the agreement was, again, more ambitious in appearance, covering 188 signatories. 149 countries stated a numerical target, but only 117 actually had clear quantifiable targets. So for those, the targeted reduction in emissions amounted to 7% on average over 14 years. So I should add that there's huge variations. Huge variation across countries around these numbers, and these are illustrated here. So this is the Kyoto Protocol. Countries in gray did not sign the Kyoto Protocol. Countries that signed received colors from green to red, with those in green pledging larger reductions, those in red pledging larger increases relative to 2005. Yellows and oranges, as well as light green, show the values in between. This chart here shows the pledges for Copenhagen, with a predominance of targeted reductions from 0 to 25%. And finally, this slide shows the quantifiable pledges from the Paris Agreement, displaying a significant range in targets. So let me turn to the comparison of targets and achievements. So starting with the Kyoto Protocol, this chart plots actual reductions in emissions in the vertical axis against targeted reductions in the horizontal axis. A positive number here is a reduction in emissions, and a negative number is an increase in emissions. So let me show you the same chart without the outliers, Sweden and Ukraine. So this is the same as before. Countries to the right of the y-axis, in shaded gray here, had targeted a decrease in emissions. Countries to the left of the y-axis had targeted an increase in emissions, all relative to the levels of emissions in 2005. Countries above the x-axis, given that this is the name of sorry, let me go back to that. But countries above the x-axis are the ones that actually experience a reduction in emissions. And countries below the horizontal axis recorded an increase in emissions. So countries above the 45-degree here are the ones that achieved or exceeded their targets. The task of achieving the target will be easier the more to the west of the picture the country is. And so the shaded cone here highlights the countries that both pledge a reduction in emissions and achieve their pledge. And it's really a small minority, showing that not only were the targets in the Kyoto Protocol in all rather unambitious, but also few countries complied. And let me now turn to Copenhagen, again, excluding outliers here, to see the picture in a better scale. Again, what's interesting is that if you look at the cone of compliance with targeted reductions, there are very few countries falling in there. Of the set of compliance, those above the 45-degree line, most had pledged no reductions in emissions. So our data ends in 2018. There are still a couple more years to go for Copenhagen, which ended in 2020. And certainly the pandemic could have helped in reducing emissions during those years, but it wasn't necessarily a planned reduction, but a forced one. Let me now turn to the Paris Agreement. Yes.
Silvana, yeah, okay, you're going to talk about the Paris Agreement. There was a clarifying question about the Paris Agreement, about whether there was a 7.19% reduction since the signing, I think is what.
Yes.
And they want to know over what time period that was.
That would have been over the 14 years of.
Okay.
Yeah.
So from 2016 to 2030, basically, is the.
Yes.
Okay.
Yeah.
So I hope that answers the question for the person who asked it. Okay.
Yeah. Sorry, I'm not watching the chat, but yeah.
No, I'm watching the chat.
Good, Steve. Okay, excellent. Yeah, so, and part of the point is that, again, many countries express their reductions relative to different baseline years. So that's why we thought it would be helpful. Okay, let's focus on 1 year and express all the reductions relative to the beginning of the agreement. So let me now turn to Paris. We can only observe the pledges at this stage, as it's too early to assess progress. The Paris targets are for 2030, as Steve just said, so we cannot really discuss compliance. So this plot is different from the other two I just showed you. It shows that targeted emission reductions in the vertical axis. This is the target, against the level of emissions in 2014 on the horizontal axis. Actually, we use 2014 here because this is the last year for which we have the data on greenhouse gas emissions for all countries. After that, we need to move to CO2 only. The correlation between these two is very high, so it doesn't make much of a difference for this picture, at least. So the point to note here is that there are still many countries in negative territory here, below the x-axis, implying that for them, the Paris Agreement means a targeted increase in emissions. So these are all the countries below the zero axis or the x-axis here. So the variation or range of pledges is huge in Paris, with countries like such as Sweden, for example, pledging more than an 80% reduction relative to 2014, together with Namibia, Romania, all pledging targeted reductions above 80%. In contrast, other countries have large targeted increases in bounds. Some, as you can see in the picture, exceeding the 100% and well ahead of 50% as well. So, as I said before, the targeted reduction from Paris, based on the elements we have now and vis-a-vis 2014 emissions, stands at 7%. So let me now turn to the impact of the various climate agreements and actions. This set of exercises that I will show you now do not involve targets. We focus only on the outcomes resulting from signing the pledges, but not on the pledges themselves. Remember the table I showed you earlier with the various covariates for emissions. To this set of variables, we add indicator variables for when and whether a country signed an agreement or implemented a policy change. And so let me start with the effect of climate agreements. The regressions say that the Kyoto Protocol led roughly to a 30% reduction in emissions in signatory countries when compared to the countries that did not sign the pledge. Now, how do we put this number together with a small average pledged 5% reduction that I showed you earlier? And to reconcile the figures, it's important to understand that countries that did not sign the agreement, the Kyoto Protocol, saw a significant increase in emissions. In other words, this 30% effect of Kyoto is coming from the comparison with a control group that kept a significant trend in emissions in this period. So while Kyoto did not lead to a large net reduction from 2005 onwards, it put the lead on more increases. Signing the Copenhagen Accord, again, all else equal, led to a reduction in emissions in the order of 15%, again, compared to the group that did not sign Copenhagen. And Paris has not yet produced any reductions in emissions. Again, as I said before, this might reflect the fact that it's still early, many more countries signed the agreement, some with no real pledge or commitment to reduce emissions. So we will see as time passes. The third and fourth columns here tell us that having a measurable target reduce emissions by nearly 10%, again, compared to cases without quantifiable targets. So numerical targets do help. And I guess by transitivity, having clarity in the targets should also help. Now, since the 1970s, and partly in response to some of these agreements, we've seen an increase in the number of laws and policies that have been passed by many countries to reduce emissions. And this table gives an idea of that progression. Before 1970, there were only 8 climate laws and just 1 climate policy across all countries in our sample. Now there are 775 laws and over 1,000 climate policies across countries. And the number of countries with at least 1 law or policy is 156 or 176 respectively. And so the key question here is whether they made a difference. And that's what we investigate in the next set of regressions. What we find is that the number of climate-related laws contribute to lower emissions, whereas the overall number of policies does not seem to matter. Some specific measures are super important, and we zoom in on 2 of them: carbon taxes and emission trading schemes. Both appear to have a significant effect on emissions. Having a national level carbon tax reduces emissions by roughly 20%. Having an emission trading scheme or being part of the emission trading scheme reduces them by 28%. Again, all compared to the counterfactual without taxes or without emission trading schemes. Other specific policies do not have a materially large effect, though some are statistically significant. They do not appear to be economically significant. Now we go on in our work and analyze the dynamic effects, taking into account the dynamics, how does this evolve over time. These four plots illustrate the responses of emissions to the four policy changes that I highlighted before. Signing the Kyoto Protocol in the top left, signing Copenhagen in the top right, having national level carbon taxes, bottom left, and introducing the emission trading system in the bottom right. And the blue lines here show the point estimate, what happened to emissions if every year following the intervention. So, for example, the top left plot says that 7 years after Kyoto, emissions have fallen 20% relative to the control group that we defined. The effect from each of the four interventions builds up gradually over time. By the fourth and fifth year, the symmetric effects are broadly similar to the results I showed you in the previous regressions. So let me turn now to the impact on other variables. So we extended the work to study the impact of the various climate change measures on both GDP growth and on inflation. Without going into the details, let me just say we don't have any significant effects from the agreements or the two policies, national level carbon taxes and ETS, on GDP growth. The effects are not clearly geared towards one side or the other. The prior here should be that measures should be costly in terms of GDP growth, but that does not appear to be the case. Maybe there's some substitution, maybe it's the fact that implicitly and through other policies, fossil fuels are inefficiently subsidized in many countries. So removing those subsidies don't hurt GDP that much. Similarly, for inflation, there's no clear effect. So let me now turn to the conclusions. Going back to the initial questions, climate targets were not always clearly specified, and this is a problem that will become more important for the ongoing Paris Agreement. Our first observation is that it would be very helpful to have more transparent goals that we can understand so that there can be proper accountability. Second, countries' compliance with agreements has been partial at best. However, signing the Kyoto Protocol and the Copenhagen Accord led to significant reductions in emissions when compared to the group of countries that did not sign these agreements. The effect of the Paris Agreement are not yet visible in the data. We also find that having quantifiable targets helped in reducing emissions. The absolute falls in emissions tend to increase with the number of climate laws enacted by countries. But individually, there are only two measures that seem to matter significantly. One is having national level carbon taxes, and the second is being part of an emission trading scheme area. Both are associated with material reductions in emissions when compared to a control group without those policies. Other laws and policies don't have an individually large effect. Finally, while signing the agreements helped to reduce emissions, again, compared to the counterfactual, the net reductions themselves were very modest. And much of the significance here that we're capturing stems from the fact that the control groups continued to increase their emission levels materially throughout this period. The agreements help to curb the trend, but not eliminate it. So overall, much more ambitious targets will be needed to offset the effects of emissions on stemming from GDP and population growth. And I will pause here, Steve, if that's okay. I'm happy to take questions about this research.
Thanks. Thanks very much. Let me just remind everyone again that if you do have questions, please put them either in the chat or the Q&A. I can see both of them. And I have to say, I will say, Silvana, that if I'm giving a presentation, there's no way I can watch the chat. So there are people who can do this, but I don't understand exactly how. There are two questions so far. One of them is very simple, and that's whether or not you've posted your data set for people, or whether you are going to be able to share it. If so, we can put a link if there is a place for that, we can put a link with this on the eAccess Forum website, where there will be a little place where people can watch this and see your slides. So I don't know if you've done that.
Yeah, I don't think we posted the data set, but I'm more than happy to do that. So, and actually this is a good reminder that we should do that.
Yeah, I think, I mean, it's pretty, what you've put together, I mean, my casual observation, not having done work like this myself, but done some data work, is this is a pretty amazing, amazing set of amazing data set, and has been an enormous amount of work. So I think it would be great to share it. There's a question about whether or not you've looked at efforts into green innovation as an outcome variable, and whether countries that signed international agreements have objectives to be first movers in trying to develop green technologies. So this would be sort of a spillover question. Do you have any sense of that?
Yeah, we didn't have the data, or we didn't look for the data for that. I think it's it would be a great project to try to follow up on that, but yeah, we haven't done it, and I don't have a good sense of whether
There's another question about, does the evidence for the granular analysis of carbon taxes and emissions trading system schemes suggest how the outcome of these interventions can be extrapolated? I think this is related a little bit to a question I have about sort of, how much do you think, if you did this bigger, would you get closer to your targets for the people that did only a little bit of it? I guess it's sort of another way of asking that.
Yeah, so how to scale up this?
Yeah,
in other words,
yes, exactly.
Yeah, I mean, yeah, I think so. What we have here is very coarse. It's a very coarse measure of having or not national carbon taxes. Some people did a much better job at going granular for certain parts of the world. I think Metcalf did work for Canadian provinces, and him and James Stock have worked for European countries, and these are all aligned in the sense that they all go in the same direction. Obviously, there's a question of scalability always with this type of interventions, and we cannot be certain that scaling it up will lead to the same effects, but definitely this is suggestive that this can help with the reduction in emissions, and at least at this level for now, they're not causing any they're not costly in terms of GDP losses.
Yeah, just coming to that, do you have a sense as to why it's not costly in terms of GDP losses or inflation? I think the inflation number, I've seen these results, elsewhere, that there seems to be very, very little impact. Do you have any intuition as to why the impact is so small?
I mean, one possibility is that fossil fuel itself is very inefficient, and we are subsidizing, an activity that's inefficient. And so once you remove that, you're not, you're just offsetting a subsidy that in itself is inefficient. The other is that there is hope for substitutability, and we've been moving towards cleaner technologies. So maybe that scope is there to reduce the impact on GDP. And the other, I guess, is that most of these interventions have been relatively small so far. So again, the effect on GDP has not been material. But yeah, the more we make this, the more we work on substitution, then through innovation, the less costly this will be in terms of GDP.
So yeah, so is there any, if I looked at your at some of your results, it suggests that I might prefer, I'm not sure this is the proper reading, but if I just look at your impulse responses, right, what I see is bigger effects of emissions trading systems than of carbon taxes. Is that an accurate conclusion? Or is that an artifact of something in the estimation?
Yeah, I think I would not compare the point estimates or not read too much from, just those point estimates. There are standard errors around, and I don't think I can, claim significantly different results. But the other point is, again, these are coarse measures. And as I said, this is about having or not a national carbon level, carbon tax. Once you work on the optimal carbon tax, you might be able to improve on the ETS and have a better outcomes even. But yeah, I mean, I would say they're on the ballpark from what we have, but I wouldn't read too much on the quantitatives because this is not high precision. It's just having or not a national carbon tax.
Right. Let me remind people to put their questions in one way or another. Yeah, I mean, one of the reasons that would be so important, I think, is that obviously a lot of people don't like taxes for various reasons, but of course, one reason not to like them is that they don't want to they worry about giving more revenue sources to politicians, and emissions trading systems don't necessarily do that. In the same way. I mean, they can, depending on how you set up the permits, but and if you auction them off or something. But in any case, you have a this is the first time, at least I'm not that knowledgeable, but about this everything in this area. But it's the first time I've seen a data set that was this comprehensive. Is there a sense in which the sort of what we think of as the advanced countries are behaving differently from from these much poorer countries in all of this? Do you think?
Well, I mean, they've been the first signatories to this agreement, and they've been leading in that regard. But obviously, if we look at the stock of gases in the atmosphere, the biggest contributors have been advanced economies, and we go back to the Industrial Revolution. I mean, when all this started. So in some sense, it makes sense that they're doing more, and we clearly have to do a lot more because the clock is ticking, and we need to move quickly on more ambitious targets. But there are many developing countries that are super committed to stopping climate change, and they're doing enormous efforts as well.
Oh well, here's a question which is I'm not sure I'm not even how to read this question. I'll just read what the person wrote. What will be the effect of a nuclear war in Ukraine and Europe in relation to meeting the climate goals set by, I guess but I'm not sure what that, if you have maybe we can ask about the war and what you think. Let me soften this, because I think a nuclear war in the Ukraine may be too much. What impact do you think the war in Ukraine is having on climate objectives in Europe and the rest of the world right now? It's changing relative prices quite a lot, but
it's changed relative prices a lot. It really awoken us to flashes of the future when we really need to accelerate the substitution towards other technologies. So, I mean, some optimists would say, well, the silver lining is that there's no silver lining anymore. Let me just retrace. But if there's one thing is that there could be, you know, a faster move towards greener technologies after this horror. But who knows? It means that's more of a hope.
Right. I think you know, the nuclear part of this war, I think, is gets back to us destroying the planet. So we sort of, I don't want to think about that much. But back to this question about again, a more general question, and to ask about this. I think there's a tension between the poor countries and the rich countries in this carbon emissions. As you pointed out, since the wealthier or advanced economies have been the ones who have basically created the stock of carbon that's in the atmosphere, they now turn to the poorer countries. And I've heard some people say this, that it seems as if the goal of the wealth of the developed world is to keep the less developed world from developing. And so what can we do about the need to ensure that poorer countries actually do develop at the same time? Because you present this very compelling and very intuitive evidence that basically development is carbon intensive, or at least historically has been. So what do we do for the lower, less developed world?
Yeah, I mean, again, this has to be a responsibility of developed or advanced countries to really put the effort to develop green technologies, and so that's the new way of growing, through green technologies, rather than what growth has been in the past few centuries. So it's about doing the investments that are necessary, and this will involve, again, private sector, governments, all being involved in doing this technological transition towards green. Developing countries have every right to develop, and it's, again, given given that we've all contributed to this stock of gases, I think we all bear a responsibility to accelerate that transition and to invest in the new greener technologies.
Right. I felt for quite a long time that we should find a way to pay Brazil not to cut down the Amazon, but obviously no one has yet done that. There is another question. This is let's talk about climate politics. The question begins: quantifiable targets help. That's a good finding. How should the nationally determined contributions of the Paris Agreement or of a future agreement be renegotiated to provide the incentives for more and stricter quantifiable targets? Given there are a few large influential players, and the questioner mentions China, the US, the EU, and India, could you say what you see as each of these and their possible contributions? That's sort of a multi-part question. I'm not sure. Did that make sense?
Yeah, I mean, so I would say, having soft targets or unspecified targets, that's almost like not having them. So it's very important that, again, people invested on climate change, really ask for clear targets, measurable targets. Without those, it's very hard to have a conversation on accountability, and so I would say this should be the way to set goals. Otherwise, we find in a situation in which everybody signs the agreement, but it becomes meaningless because we're not really serious about the actual goals. I know very little about politics, and that's for others to
well, I mean, I think even you know enough about politics to know that politicians don't want specific targets, right? They don't want to, they want to figure out a way to not be accountable.
Yeah, and there's a
So-
problem with numeracy as well. I mean, in understanding what these numbers are. Again, I mean, it was surprising to find that, again, countries were stating these reductions, but relative to different baseline years, and in the end, it becomes meaningless. So some countries were stating reductions, saying the Kyoto Agreement relative to 1999, to 1990,
90.
where they were already, had reduced their emissions, by 2005. So then, what was left was an allowance to increase emissions rather. So, there's a numeracy problem. We can say, yes, I'm committed to reduce emissions, by 30%. And this might sound very stupid, but, if your baseline year is 1990, that's very different from saying, 2016 or 2020.
Well, maybe we need an independent agency that's tasked with reducing carbon emissions and setting targets. And one of the participants has asked about the U.S.-China climate working group cancellation. I confess to not knowing about this, but whether that may have an impact on emissions decreases after the Paris Agreement. I guess maybe the more general question is whether you think the Paris Agreement actually has much of a future given the increases in geopolitical tensions that we're seeing.
Yeah, I mean, clearly these tensions don't help. We have a global problem. It needs a coordinated solution. It needs cooperation, and we need to have a sense of a dialogue across countries to work together, because again, this is a global problem. Having tensions, having wars, I mean, that's the worst, when you have a problem of this magnitude. So I would say all these tensions are getting on the way of really working towards a solution. And again, my sense is that cooperation is possible, and there were instances in which countries worked on global problems and thought together and worked on global solutions. But yeah, definitely these tensions don't help, and we need to get mature. There's, the clock is ticking, and if we don't work on the problem of climate, then they're really fighting about something that is worthless, because at the end, if the planet is diminished or at risk because of climate change, then there's no sense to have these petty fights right now.
Well, I think that another answer to this question is that the kind of work that you're doing is exactly what we need to try and push people into having the kinds of agreements, helping them understand what types of agreements are likely to yield success in meeting the objective of reducing emissions and ultimately keeping the level of carbon below the sort of budget that we feel that we have in the long run. I don't see any questions left, and I've run out of things that I actually might know something about. So let me thank you again for taking the time out of what I know is an extremely busy schedule among all of your various roles that you have. Thank you for speaking to us. Let me remind all of the participants in the webinar that we do have another webinar coming on the 10th of October. And let me also emphasize the existence of the E-Axis Forum prize for outstanding research conducted by young scholars. So those of you that either are young scholars yourself or are in contact with them, please submit your work. We'd love to see it, but that has to be by the end of the week. So thank you again, Silvana, and with that, I bid everyone a good morning, afternoon, or evening, depending on where you are.
Thank you, Steve.
Bye-bye.
Thanks again. Bye. Take care. Bye-bye.